So this is another way of checking, that you know how the steps work. You're going to have all the reactions. Like if you Xerox the whole thing, right? The last page that you had on the exam, I'll try to make it a clearer copy. But you're going to have an equivalent of what you had on the last page of the exam. So you've got all the steps. I am going to blank out the numbering system though. Aww. And also blank out the names of the enzymes. That seems fair, right? No. Well, I'm doing it anyway. All right. Let's move to some little enzyme kinetics.
Number 7, 8, and 8.
Oh, well, I wouldn't skip to 9. Okay, so we'll do number 7 first. All right, which of these statements is true? Remember I kept telling you that I was going to ask questions about why things happen? Okay, which of the following statements is true? Glucose 6-phosphate is converted to fructose 6-phosphate because aldehydes can't react with glycine in H2 groups. No. An aldehyde can react with a glycine. I haven't gotten to D yet. Just shut up. Okay? No, aldehydes can react with glycine. We never said that was a reason why things didn't happen. So that's not it. Glyceraldehyde 3-phosphates converted to glyceraldehyde 2-phosphate because glyceraldehyde 3-phosphate cannot turn into an enol. No, it can turn into an enol. It's just you're going to lose the phosphate if you turn it into an enol. And you don't want to lose the phosphate. The reason you use the mutase to go from putting it in the 3 position to putting it into the 2 position was to save the phosphate. You can see all these little pickets walking around. Save the phosphate. Okay. All right. That was really bad. The reaction of taking PEP and turning it into pyruvate is an oxidation. No, it is not. There's no oxidation occurring there. Everybody keeps their electrons. Look at all you did. Look, here's what happens. That goes there, and that picks up a hydrogen. This carbon there is a double bond in either case. So it's not an oxidation. You're going from the enol to the keto form. You're going from the enol to the keto. That's not an oxidation. We never call it an oxidation. It doesn't involve a Another clue for you is it does not involve what kind of enzyme? Dehydrogenase. It involves a kinase. Okay? D, the lactose will not work directly. Notice the word directly in glycolysis because its number 4 carbon cannot be oxidized. No, that's not the reason it doesn't work directly in glycolysis. Why doesn't it work in glycolysis? We went through that at the beginning of class. The OH group's pointed the wrong way. In glycolysis, glucose carbons 3 and 4 are oxidized. We got a big hairy glucose here. 1, 2, 3, 4. All right? This is the bond that you chopped, right? This guy here, number 4 carbon there. Okay? The number 4 carbon, if we keep that numbering system, turned into the aldehyde in glyceraldehyde, right? The fate of that baby was to get oxidized. That's the one that the dehydrogenase attacks and turns into the glycerin. Right? If you look at the other piece, after you've done the cleavage, the other piece, carbons 1, 2, and 3 look like that. That was the dihydroxyacetone phosphate. What happens to this? This gets isomerized. Into that. This carbon here turns into an aldehyde. You don't do it with that one because it's got a phosphate on it. Okay, so this turns into an aldehyde. All right? And what happens to that? The same thing that happened to that. So carbons 3 and 4 are the ones that are oxidized. For the record, carbons 1 and 6 are the ones that keep going through with the phosphates on it. The first and the last one go through is the ones with the phosphates on it. Okay. Everybody see that? My eraser trying to escape. Okay, now we'll do number 8. There's all these sugars to play with. Isn't that exciting? Okay. We specify the form, alpha pyranose. Alpha pyranose. Okay? So what you first do is you draw down what the alpha pyranose form looks like. God, that looks like it's unbelievable. Okay, that's pyranose is the 6-membered ring. Alpha means the OH group is going to point down. Since this is an aldose, that means we're talking this is carbon number 1. Okay? Now, so this means this is number 2, 3, 4, 5, and 6. What are we going to do with number 6 down here? We're going to stick it up. Okay? Now we have to figure out what to do with the other one. The OH on number 2 is on the left. Where's it go? Up or down? Up. OH on number 3 is down. Where's it go? I mean, it's on the right. Where's it go? Down. Okay. Number 4. Up. Number 5. In the ring. All right. Okay. Everybody got that in the ring? You got it? Okay. It's in the ring. Okay. What if I wanted to do this? Just to pick another one. What if I said I want this in the beta pyranose form? Now, first thing, you would not pick an answer like this is not possible. Would you? No, you wouldn't. All right, pyranose. This means it's like this. Okay, and the OH is up, right? Because it's in the beta form. This is carbon number 1. So what's hanging off here is what? Where'd the CH2 come from? God, that was an evil laugh, wasn't it? Which carbon is number 1? That one, right? Right! So what's hanging off of here? An H! Alright? To form that 5-membered ring, we use this carbon. 2, 3, those four carbons, and that